I'm Mr. Ish and I welcome you to this video. Thank you for watching. Everything that I'm showing you in this particular video I have seen in some way, shape or form on a standardized exam such as the SAT, but not solely the SAT exam, in other exams as well. If you're looking at a quadratic equation, you know from that we can utilize a quadratic formula to determine the value of x. But specifically for this quadratic formula, you have this component right over here, which you know is called the discriminant. In terms of solutions, the discriminant has three possibilities. When b squared minus 4ac is larger than 0, you know you have two real solutions. When b squared minus 4ac is equal to 0, you have one real solution. You know that to be the case. When the value b squared minus 4ac happens to be less than 0, you bring in a negative in terms of the square root, and then you have two imaginary solutions. In this video, we're focusing right here on two imaginary solutions. But in terms of the graph, this one right here, the very first scenario, could be something like this, where you have a quadratic parabola which is intersecting the x-axis at 2 points. You could have another situation of the same representation such as this, two intersection points, but in these cases you're having two real solutions because the discriminant was larger than 0. In the secondary case, b squared minus 4ac equals 0, that's a situation where your parabola may just have one intersection point right here, or you could have a situation such as this, a single intersection point, therefore one real solution. However, this right here being our focus for this particular video, imaginary number roots, you could have a situation such as this where your parabola will never touch the x-axis, or something like this where it'll never touch the x-axis, therefore you'll never have any roots, you'll never have any x-intercepts. Your roots are synonymous with your x-intercepts. In these type of situations, or even something like this, you know you're never touching the x-axis, you're not going to see any roots. Any roots will be imagined roots or imaginary roots. So let's look at this concept because it shows up on exams. Very quickly, if you had something like this show up, you have a negative here in a square root. You know the square root is an even numbered root. 2, index is 2. You know you can get rid of the minus, but you have to bring an imaginary number by doing so. You've eliminated the minus, the negative sign, but you brought an imaginary number, and then you can complete this and you can do that. And that would be your answer. And how about this, minus 16? You know you can bring an I out and you're looking at a 16 now, and then you bring your 4i. But in terms of completeness sake, you can do plus and minus, because you're looking at the positive and the negative roots. But you see how these imaginary numbers develop. These imaginary numbers develop by the presence of a negative in an even numbered root. A square root is an even numbered root. You can't expect an imaginary number to come out of this minus 8 but cube root, because that's a minus 2. You have an odd numbered root. But we're focusing here on the even numbered square root for which these imaginary number roots will develop. So why do you have to know all of this? Because of the two particular type of questions which can show up on these type of exams, and I'm going to show you these two questions. You have to be able to work and think backwards for these. The question will be this: plus and minus 2i represent roots of an equation. You have to determine the equation and you have to graph it out. You have to determine the equation and you have to determine its graph. How can you do that? Given that these are the roots of a certain equation, what would that equation be and what would that graph be? When you're looking at plus and minus 2i, you have to think and you have to work backwards. The only way you had an imaginary number come out was you had a square root with a negative, and the only way 2 came out was you had a 4, because you know 4 in terms of root, square root, gives you a plus and minus 2, and you know this would have given you a plus and minus 2i, but you are not answering the question by presenting that. You have to determine what the equation was. The only way you could have had this situation was if on the other side of the equation you had an x squared, because you took the square on the other side, it generated a root. But the only way you could have had a minus 4 on this side of the equal sign was you had something which was x squared plus 4 is equal to 0. And this right here would be the equation for which these roots would exist, imaginary roots. Why? You can solve it. X squared plus 4 equals 0, x squared is equal to minus 4, x is equal to plus and minus root of minus 4, and x is equal to plus and minus 2i. So we've determined what our equation was, and the question was represent these roots in terms of an equation and then graph it. Here's our equation, we can graph it now. And let me graph it for you. You know it's an equation of a parabola shifted up by 4 units. Right over here. But look at it, It's pointing upwards. It'll never touch the x-axis. There'll never be any real x-intercepts. There'll never be any real x solutions. No real solutions. Everything here will be imagined, and your imagined solutions would be these, plus and minus 2i. So I've given you the graph and I've given you the equation. You just have to work backwards and the question has been solved. Let's look at this question. 1 plus I, 1 minus I represent roots of an equation. We have to find that equation and we have to graph it. We're looking at imaginary solutions which are 1 plus I and 1 minus I. How can you go about determining this? This is slightly harder. You know an imaginary I came from a root of a minus 1 because we don't have any coefficient here with I. It's just a plain I, because this would have given you in terms of the square root of this negative plus and minus I. So we know somewhere we have a root of a minus 1 developing, but then we have this 1 attached, which means somewhere along the way we have a plus 1 being added in terms of our equation. So we know we have this forming and we have this in our equation. Let's somehow put that together in terms of an equation. How about you have something which looks like this, x minus 1, and then you have right here root of minus 1. Because when you take this minus 1 on the other side, you get this plus 1, which you're seeing right over here, plus 1. But the only way you can get a root on this side is if you have a square root on that side, and you're seeing that develop. You're getting x minus 1 whole square is equal to minus 1. You take the root on the other side, you'll get your root of your minus 1, which will give you this. But the only way you can have a minus 1 on this side of the equal sign is if you have x minus 1 whole square, you take it on this side, plus 1 is equal to 0, and this right here is your equation. X minus 1 whole square plus 1 equals 0. Because if you were to solve something like this, you would do x minus 1 whole square is equal to minus 1. Then you take this power on the other side, your exponent, you'll have root of minus 1. Then you'll do the minus 1 on the other side, you'll have root of minus 1 plus 1. But this right here will give you your plus and minus I, and then you have plus 1, and this right here are your two roots, 1 plus I, 1 minus I, and your equation here is verified. But now we have to take this one step further and show you the graph, and let me show you the graph. The graph is no different than you being able to determine that you're looking at x minus h whole square plus k. This is the equation of our parabola. And you know this is in the standard form. There's a positive 1 over here. It's a parabola which is aimed upwards with a vertex 1 comma 1 aimed upwards, and that right there would be your parabola right over here. You see how it's aimed upwards? It'll never touch the x-axis. It'll never generate a real solution. It'll never generate real roots. It can only generate imaginary roots because there's no intersection of your curve with the x-axis. But this right here is exactly your answer, and this right here is exactly your curve, which represents these roots, 1 plus I and 1 minus I. And you have to be able to work backwards and understand the fact that if your curve, your quadratic parabola, never touches the x-axis, you can't have real solutions. You can only have imaginary number roots or imaginary number solutions. You could have put the word over here solutions and it would be just as fine. And the video has fulfilled this purpose. So remember, where the discriminant is less than 0 are the cases where you're generating imaginary number roots or imaginary number solutions. And that's it for this particular video. Thank you for watching. Have a great day. Bye.